Okay, guys, with all the kind of chaos that's been going on, we're going to switch from our guided notes in class that we usually do and just switch over to doing notes longhand. So the last section that we were working on in class was graphing polynomials. And let's just start off with a polynomial function, negative x times x plus 2 times x minus 3. And this is a polynomial that is called in factored form. And we've seen this problem in class, but if we wanted to convert this to standard form, we would have to distribute this out. So we distribute the two binomials, x plus 2 times x minus 3, to x squared minus 3x plus 2x minus 6. And then when we distribute this in and combine like terms, what we'd get is we'd get negative x to the third. We have a negative 3x and 2x, which makes negative 1x. Timesing by another negative x gives us a positive x squared. And then negative x times negative 6 gives us positive 6x. And that gives us our polynomial that's written in standard form. Now, what we talked about the last thing in class was using the leading term, negative x cubed, to identify the end behavior. And the last thing we had talked about was if the degree is even, then the two ends of the graph have to be either doing the same thing. So either both ends of the graph are pointing up or both ends of the graph are pointing down. And if the leading coefficient is positive, the graph's pointing up. If the leading coefficient is negative, it's pointing down. In this case, we see that we have a degree that is odd. And the fact that the degree is odd means that the two ends of the graph are doing opposite things. So either we have the right side is approaching infinity, and the left side, as x goes to negative infinity, goes to negative infinity, or vice versa. And if we look at the one here on the left, from left to right, it's traveling uphill. So this is what happens if we have a leading coefficient that's positive, and then on the other one, it's traveling downhill. This is what happens when we have a leading coefficient of negative. So when we look at this polynomial function here, f of x equals negative x to the third plus x squared plus 6x. Since this is an odd degree and a negative leading coefficient, what that means is, in terms of the graph, is as x approaches infinity, the y values have to be approaching negative infinity, and as x approaches negative infinity, the y values, f of x, is approaching positive infinity. So we know the two ends are doing opposite behavior, and the negative leading coefficient tells us that overall the graph is traveling down from left to right, from negative infinity to positive infinity. Now, if we want to create a more detailed picture, what we're going to do is we're going to bring in the concept of intercepts. So, real quickly, if we want to find the y-intercept, just to kind of refresh your memory, we set x equal to 0. So if we go to our function here, and I'm going to use the factored form, f of x equals negative x times x plus 2 times x minus 3, because obviously if it's already been factored, it's a lot easier to work with. But if I replace all the x's with 0, the fact that we have this first multiplication being just 0 means that we get f of 0 equals 0, which means that we have a y-intercept at the origin. And then if we want to find the x-intercepts, we're going to set f of x equal to 0. And that's really the key to why we want to have factored form. Because if we set it equal to 0, we can already use the product property, which says that since all these are being multiplied, we can set them all equal to 0 individually. And we get x is 0, x is negative 2, x is 3. So, which we knew it would cross the x-axis at 0, but this is now telling us it crosses the x-axis at negative 2, and it crosses the x-axis at positive 3. Now we don't have any detailed information for our y-axis. Okay, that's where we bring in a little bit more of a calculus based if we wanted to actually get a detailed picture of specifically. We know this graph starts up here, goes down here, it has to pass through these 3 points. We don't know how far it goes down or how far it goes up before it turns around. Okay, that's where calculus leads to. But for right now, based on the information that we have, this is a rough sketch of this polynomial function in standard form, which is equivalent to the polynomial function that is written in factored form. Now, what we're leading into is you'll notice here on all of these, it went straight through. Well, here's the dilemma. We could have graphs that look like this. They could go, instead of going down and going straight through the x-axis, they could make like a parabola. We could have an S shape, or it could indeed just pass straight through. Okay, so we need to be able to know when does it cross the x-axis, when does it create an S shape at the x-axis, when does it go straight through. And this polynomial that we just did happened to just all go straight through. But we're going to just take a quick bounce back to transformations for just a moment. We're going to take a quick bounce back to just transformations. If we go back to the function f of x equals x minus 1, this is going to be a linear function that crosses the y-axis at negative 1 and has a slope of up 1 over 1. Okay, and the big thing I want you to realize is this x-intercept is at 1, 0. Now if I graph x minus 1 squared, we know that this function here is going to start out as a parabola. It's going to start its life out as a parabola that's centered at the origin, but then the transformations tells us that this minus 1 is going to move the graph right 1 unit. Okay, and so what we see here is we still have an x-intercept at 1, 0. However, this is now U-shaped, whereas over here it crosses x-intercept at 1 and this passes straight through. And then the last one we'll go over is x minus 1 to the third. And that's a cubic function, and we know it's a cubic function which is going to be start its life off as a basic S shape, but then once again this minus 1 is going to take the graph and move it right 1. And so when we have a cubic function, what we see is we still have the x-intercept. It's still at 1, 0, but the difference is the S shape. Okay, and these different shapes is dependent upon the powers here, the 3, the 2, and technically this x minus 1 could be written in parentheses with a power of 1. Okay, and so these powers are called the multiplicities of the zero. Okay, and the multiplicity specifically tells us what shape it's making at that specific. Now, so what that means is if a 0 has a power of 1, it's always going to pass straight through. If a 0 has a power of 2, it's going to be a U-shaped. And actually it's going to have a U-shape if it's a power of 2, a power of 4, a power of 6. Anytime we have an even power, we're going to have a U-shaped graph. It's going to be a straight line if we have a power of 1. And then it's going to be an S shape if we have an odd power greater than 1. So if the power is 3, 5, 7, whatever it may be, the odd power is going to be, the shape's going to be an S shape, provided that it's an odd power greater than 1. So with that said, if we want to graph f of x equals, say, 1/2 x plus 2 squared, x minus, let's do x minus 3, like this. So if we want to graph this, the first thing what we're going to do is we're going to figure out what's the end behavior. So what's it doing on the ends of the graph? And if you remember in class, I said we don't actually need to multiply this entire function out. This is going to be 1/2 times x plus 2 times x plus 2 times x minus 3. And in order to know the end behavior, we just have to know the leading term. So we're going to just do 1/2 times x times x times x. We're going to multiply by the leading term in each factor. And when we do that, we get 1/2 x to the third. And so what we see is we have an odd degree and we have a positive leading coefficient. Okay, so odd degree means the two ends are doing opposite. So one's pointing up, one's pointing down. And positive means the graph is traveling uphill. So we know that the two ends of our graph have to look like this. Now to figure out what's going on in the middle here, we're going to do our intercepts. So same as always, the y-intercept is plug 0 in for x. I'm going to quickly run through this. If I plug 0 in for x, that's going to give us 1/2. 0 plus 2 is 2, squared is 4. 0 minus 3 is -3. Half of 4 is 2, and 2 times -3 is -6. So we know it's going to cross the y-axis at 0, -6. Now, when we do our x-intercepts, and that's how we're going to always do the y-intercept, when we do our x-intercepts, we're going to bring in this concept of multiplicity. We're going to set the function equal to 0, and then we're going to set all the products equal to 0. And we see that, well, since the coefficient of 1/2 equals 0, that doesn't lead anywhere. So we can get rid of that equation. That doesn't tell us any information. But on this one, when we square root both sides, we're just going to get x plus 2 equals 0, which gives us x equals -2. So we know it has an x-intercept at -2, 0. With a multiplicity of 2, because that's the power that's attached to that factor. So we're going to put a dot at -2, and then we'll revisit this multiplicity just in a second. And then on the other one, x minus 3 equals 0, we're going to get an x-intercept at 3, 0 with a multiplicity of 1. So we're going to come over here, and we're going to put a dot at the ordered pair 3, 0, and then bear with me for just a second, guys, while I grab a pencil. And what we're going to do is to draw this, we're going to draw this from left to right. So we know that at -2 the multiplicity is 2, which means we have to have some kind of parabola here, which means the parabola is either pointing up or the parabola is pointing down. And then over here at 3, we know that we're going to pass straight through because of the multiplicity of 1, which means it's going to be straight through going up or it's going to be straight through going down. Now, when we draw the graph, we draw the graph from left to right. So if we are traveling from left to right, the only logical parabola would be for a parabola that's opening down right here. And then we're going to pass through this point, and it'll always just go straight through the y-intercept. And then this point here has to be passed straight through. And we don't, the only way to pass straight through is to pass straight through going in an upward direction. And if we do that, we see the graph does indeed end up where it's supposed to end up at. Now, in terms of how far this goes down, I know it looks like it might go down at -7 based on my scaling. We don't know that information. But based on the information we have, this is the best sketch that we can come up with for the function f of x equals 1/2 x plus 2 squared times x minus 3. Alright, so now let's do an example of working backward. Write the function of the graph shown. So let's just say we happen to have a graph that looks like this. Okay, so it has an x-intercept at 4, 0, an x-intercept at negative 4, 0, and the y-intercept's at 0, negative 6. And we see it's a smooth continuous curve, so this is going to indeed be a polynomial function. And so what we're going to do is we're just going to kind of work through this backward. So since we have an x-intercept at negative 4, 0, we know that the factor is going to be x plus 4. Because that's the factor that when you set it equal to 0 gives us negative 4 as an answer. And then the fact that it's S-shaped tells us that the multiplicity is 3. So then that means that the factor is more than just x plus 4, it's actually x plus 4 cubed. So we'll come over here, and I know that the polynomial function is x plus 4 to the third power, that's part of it. And then over here we have an x-intercept at 4, 0, which means one of the other factor has to be x minus 4, and the fact that it goes straight through tells us that the multiplicity is going to equal 1, which means it's x minus 4 to the first power. So then the other factor is x minus 4 to the first power. And we don't need to include that. Now just like on this one here, we had a leading coefficient of 1/2. This function has to have some leading coefficient. We don't know what that leading coefficient is, but since we have another ordered pair, 0, negative 6, we're going to plug in the 0 for x. We're going to plug in the negative 6 for our f of x. And that's going to allow us to solve for the leading coefficient. So I'm going to replace f of x with negative 6. And I'm going to replace the x with 0. That's going to give me negative 6 equals a. 0 plus 4 cubed. 0 minus 4 is negative 4. That's going to give me negative 6a. This is 64 times negative 4. That's negative 256a. Dividing the negative 256 over gives us that a is equal to 3 over 128. And you can see we get a leading coefficient that's positive. And if you look up here, look, we have a x to the third, and this is x to the first. So our leading term would be 3 over 128, and then we've got x to the third, and we've got x to the first, which is 3 over 128 x to the fourth, which is even. And the fact that it's even means that our two ends of our graph should be doing the same thing, which they are. And the fact that it's positive means that the two ends of the graph should both be pointing up, which they are. So that checks. So putting all this information together, we get that the polynomial function in factored form is 3 over 128 x plus 4 to the third power x minus 4. Alright, bear with me for just a second, guys. Alrighty, guys, we're going to call it there for today. This should give you enough information to do sections 5.1 and 5.2, which is on page 343 and page 351 respectively. So try these problems, email me if you have questions. I'll get the next video posted probably in the next day or two, but for right now this should get you going on the polynomial assignment. And then also in the next day or two I'll probably be posting a video of just kind of like giving everyone a outline of how the class is going to go for the rest of the semester, try to answer as many questions as possible. So feel free to email me if you need help with homework. Otherwise, guys, I'll see you in the next video.